Hey kiddos, happy week 7. This is our asynchronous class time. Today's goals are to discuss properties of fixed magnets and how to describe their magnetic field. And then we'll discover the relationship between charged particles, right? Electrons, protons, and magnets. Okay. So what do we know about magnets already? Well, you guys have seen bar magnets, right? With a north and a south. You know, like poles repel, unlike poles attract. So, just like with charge, opposite charge attracts. And that's the same as magnets. I've got some magnets right here. They don't say north and south on the top, but the north end of these magnets has a dot on them. So I've got two north poles and two south poles that are next to each other, right? And I can't put them together because opposite poles repel with magnets. I can't put them together. But if I rotate one so that the north pole is near the south pole of the magnet, okay, they attract. Okay, and you know this probably from elementary school, general life, playing, stuff along those lines. All right. So here's what I would like you to do. On the Canvas page, there's a YouTube video. It's a minute physics video. It's actually a couple minutes, but it's very short. It talks to you about what is a magnet. I'd like you to watch that and then join me back here, please. All right, welcome back. That was super interesting, wasn't it? There's a lot to consider when we talk about magnets. So there are fixed magnets, there are electromagnets, there are materials that are ferromagnetic, but just because they're ferromagnetic doesn't mean that they have magnetic properties necessarily, right? The material has to have domains that are aligned. Okay. So the first thing that I would like us to do is, I know that he showed on the video how to represent magnetic field strength with magnetic field lines. I want to show you what that means, what magnetic field lines in terms of strength of the magnetic field, what direction they're pointing. Okay, so on Canvas, I've also posted a PhET simulation where you can do this investigation. And I'm going to walk you through it really quick before you do any manipulation. Okay, so the link is on Canvas. What you're going to do is, on a piece of paper in your notes, I want you to sketch the bar magnet that's shown in the simulation and label the poles. So there'll be a north pole and a south pole, and label them. Please notice that the north pole is symbolized as red and the south pole is white. Okay. Then I want you to draw and label a compass near each of the poles. Okay. So, and I'll show you what that looks like. Remember, on a compass, in terms of like how we visualize compasses, typically the red needle points north and the white needle points south, like towards our geographic north pole is where the red needle points, and to the geographic south pole is where our white needle points. So I want you to draw and label those, and then draw the field lines around the magnet. What happens to the magnetic field strength as you get further from the magnet? Okay, so let's take a look at that simulation, and you get to see all the tabs that I have open. All right, so we've got our bar magnet, north and south. You'll sketch that. Okay, and then it'll tell you to show the field. So you can start clicking on things. The brightness, the vibrancy of these tiny little compasses, right? The tiny little compasses are what are being shown here. The brightness tells you something about the magnetic field strength. And as they get darker, they get weaker. If you see inside the magnet, you can see how the compasses are aligned inside the magnet, right? And if you, all of these little swooshes are the magnetic field lines. Okay, I can show you a compass. Okay, so if I point the compass at one place or another, you can see where it's pointing. I would want you to draw that at each end. And then you have a measure of magnetic field strength. So there's the net magnetic field strength, the X component and the Y component of the magnetic field strength. And then it tells you the angle of the magnetic field strength. The units here are Gauss. That's not what we'll be using, but this can just give you a feeling of the relative size of the magnetic field strength at different places. All right. And then you can also adjust the strength of the bar magnet itself. Okay. And see what that does in changing the visualization. Okay, what changes? Okay, so play around with that. And then finally, I would like you to take a look at the click on Show Planet Earth and see if you notice anything interesting. All right. Okay, so play around with that a little bit. Please record your observations, these observations in your notes, and then come back and see me yet again.